Hey guys, welcome to the D&L Guy. Today we're going to talk a little bit about heat pumps and what is inside of our heat pumps. There's a lot of components that make up this heat pump or AC unit, and I'm going to go through most of the components inside there. Might be missing one or two, but we're going to talk a little bit about it. One of the components that I have here on the table is a capacitor. What is a capacitor? What does it do? A capacitor is something that stores energy. It stores energy inside these terminals to make sure that when your unit starts up and your compressor and motor start up, that it doesn't take the energy from your house. It doesn't dim your lights. Most common factors of a unit in the summertime going bad is a capacitor. These can be checked. We have to check these with ohms of resistance and make sure microfarads is how they test them, and we make sure that these are up to par. Now we can test these for instance, this one is a 50-5, means it uses 50 microfarads for the compressor and 5 microfarads for the fan motor. How we test these is to make sure that they meet those requirements. So this is all stuff that we test during our preventive maintenance. So a capacitor actually stores energy inside of it to help your outdoor unit start up and run. Okay, so that's one component that we have. The next component that we have inside here is called a contactor. This contactor basically takes high voltage and brings it in the bottom and actually allows it to come out the top. Now, this acts like a light switch. It pulls in and out, makes the contact, and allows that high voltage to go through. So when we have no call, the contactor is out. It's not pulled in. What we consider pulled in means that it has been energized. We check these with ohms resistance from bottom to top. We also check that's got a little coil inside here. Inside that coil, these terminals on left and right here actually are your low voltage terminals. This is what energizes your contactor from your thermostat. Now your thermostat is basically your control board. That's inside. We'll talk about that in a different video, but I wanted to go over today the components of internally inside your heat pump. So a contactor acts like a light switch. When you don't have any call, the light switch is off. When you have a call, light switch goes on, energizes this, pulls the contactor in, allows high voltage to come out of here, go and feed your contactor, feed your fan motor, and start your compressor. Okay, so a contactor is another component that's in your heat pump or AC unit, either or. It's going to be in both of them. Okay. Next component I want to talk about is a control board. AC units may not have a control board in them, and the reason why that they do not is because a control board actually controls what the unit is doing at one particular time. And what I mean by that is, in a heat pump, we actually have to monitor a lot of things. In a heat pump, we have to monitor defrost mode, we have to monitor the running of it, the temperature sensors, the pressure switches. So what we have in a heat pump is we'll have a control board. So our thermostat comes in from inside, wires into the bottom of this. We have a time delay on here. We also have a defrost sensor time delay. What we have is power comes in from our thermostat, power goes out to our unit. These terminals on the top here are labeled almost the same as the ones at the bottom. The only difference is we have to run through the board. So we have to run through our safety switches. We have to run through, make sure our low pressure is met. We have to make sure that our high pressure is not met. So we have to make sure our low pressure is above where it's supposed to be and our high pressure is below where it's supposed to be. If the high pressure is above that, it's a safety lockout. It will lock, the board will lock it out, so your unit will not run. These will fail in the midst of summertime during a storm. They're circuit boards. They're very temperamental to electricity. When I say temperamental, it doesn't take much to burn one of these up. Rarely do we see it, unless what happens is in the wintertime when it goes into defrost, we'll find that it's not going into defrost properly, and that's because it probably got a power surge through the summertime that either damaged the defrost relay or damaged the internal components of the board where it doesn't allow voltage to go through. So control board is another one that's in your heat pump. And in some AC units, it's rare, but most of the time it's in your heat pump. So This also controls defrost. I'm going to talk a little bit about defrost, and because it's important to understand that heat pumps were not designed to run below 35 degrees, okay? They're not efficient anymore. We'll talk about efficiency and SEER rating and all that other stuff, but they're not efficient when the temperature outside gets below freezing. And why? Because in heating mode, we are taking the heat away from the outdoor air. And because we take the heat from the outdoor air, if that air is colder than what is supposed to be, then our refrigerant is going to be colder. We never want our refrigerant to get below freezing, because what happens is our outdoor unit will freeze up. It'll start to get frost on the coil, and it freezes and freezes and freezes till it gets to a point. Two things initiate it: time and temperature. This board has a timer on it that goes from 30, 60, or 90. And temperature. We have what we call a defrost sensor on the line of the condensing coil. And this defrost sensor plugs right into the board under DFT. And what that does is that takes and converts the line temperature to ohms of resistance. That ohms of resistance, once it's met, is sent into these wires, into this board, sent to a relay, and that relay energizes. So when that goes into defrost, brings me into my next component, that basically, what does it do? Normally we hear it go like a set of air brakes going off on a trailer or something, like when that energizes, it shuts the condensing fan motor off. And what it does is it energizes or de-energizes. In some models, some manufacturers, it'll energize or de-energize. It'll energize, for this informational purposes, it'll energize the reversing valve. When we have refrigerant coming in, we have three ways to come out the top of this. One goes to your compressor, one goes to your condenser, and one goes to your evaporator. And we'll talk about the evaporator later, because that'll be in a different air handler inside. But what we'll do is we'll actually bring this in and allow the compressor and the condensing coil to get hot gas. And what that does is it defrosts the coil on the outside. And it'll defrost it until that sensor reads the ohms of resistance it needs to de-energize defrost mode. Now, a couple things happen in defrost mode. We then stop the flow of refrigerant to the inside of the house. Well, you say, well, what happened? How do I get heat? Very simple. When that de-energizes, we go back to the control board that is now controlling what it's supposed to do, because now we only have refrigerant going to our condensing coil, not to the inside of the home. So what do? We then initiate what we call secondary supplement heat. Supplement heat, in most cases here in Virginia, it's electric strip heat. And that electric strip heat is initiated through defrost. It sends power back to the air handler, which energizes the contactor or sequencers on the air handler, which turns your electric strip heat on. So there's a lot of things going on, when defrost is happening. So there's a lot of things to look at when units are either going into defrost or not going into defrost, how long they stay in defrost. But then we turn your electric strip heat on, and guess what? That electric strip heat is raw heat. Some of us have gas backup, some of us have oil backup, what we call fossil fuel or dual fuel systems, where once your heat pump is no longer efficient, drops out, and then brings on your secondary or supplemental heat. Could be either or, oil, gas, electric. Some people have hydronic systems that come off the water heater that feed hot coils. So that's what happens in there. So you get your control board that acts as like, hey, you need to do this when I tell you to do it, and your reversing valve, which reverses the flow of refrigerant. Now, in an AC unit, you will not have a reversing valve. There won't be one in there. And why is that? Okay, so for two reasons. One is we don't run AC in the wintertime. So there's no need to initiate defrost. There's no reason to reverse the flow of refrigerant. But in a heat pump mode, we have to, in order to get air conditioning and heating out of the same unit, it acts as a traffic cop. What it does is, it knows if I'm in heating mode, I have to come out of two of these to feed my heat, which brings back into the home hot gases into the evaporator coil, and that's our heat, okay? And then in the summertime, we shut one of these off again, and we bring the cool gas liquid into, well, not liquid because compressors can't compress liquid. It's a hot gas, hits the metering device, which brings me to my next point in your outdoor heat pump is a metering device. Metering devices there's two different types of metering devices. The first one is a piston. It's a fixed orifice. They call it an orifice. It is fixed. You cannot adjust that. You cannot get any type of adjustment out of it. However, manufacturers are now putting in what they call TXVs, a thermal expansion valve. Some refer to as, it's just a metering device. It meters the flow of refrigerant, okay? So we'll have one on the outside and one on the inside. And what that does is that refrigerant comes in and changes state through that metering device. There's a plunger inside here. There's a power head here. This goes to one of the lines on the condensing unit. This, similar to what the frost sensor did, this measures temperature. This is pre-charged with a gas inside. As that heats up, that gas goes through this little tube, goes to what they call the power head. That power head in turn opens and closes based on what it needs off of this. So if you heat this up, it's going to open more. If you cool it down, it's going to close more. It's a metering device. We're going to meter the amount of refrigerant going in. A lot of manufacturers are using these to get your SEER ratings and your energy efficiencies up. They're also building bigger coils, monster systems, because they hold more refrigerant. The new refrigerant, which is 410A, we'll talk about that in a different video, because the old refrigerants are R22, which as of January 2020, it will no longer be manufactured in the United States. It can be manufactured outside of the United States, but they have not allowed us to bring it in from any other country either. Don't worry, don't get all scared, because just a brief explanation. There's a lot of it out there right now. Is the cost going to go up? Very possibly it's going to go up, because as the demand goes up, the cost is going to go up. Supply and demand, that's our government for you. That's how it works. But expansion valve, thermal expansion valve. The next component that I want to talk about is a service valve. Service valve, king valve, takes on a lot of different names. Is there really much you should know about this? No, not really. Basically, this is more for the manufacturer, for the technician. What they put these in here for is for servicing. We have a port that comes out here we connect our gauges to. We are able, as service technicians, to open this up, close a valve down if we have to. We actually use these to test systems for leaks. We have seen a lot of these leaking. Basically, it's just a Allen head screw that screws down in here and closes the valve off. And what that does is it has rubber O-rings inside there, and they wear out after time. Once they're open, they should not have to be closed again unless your unit has to be serviced. So we always check these out. But there's two of these. One's called the suction service valve, and the other one is called a discharge or liquid line service valve. So if you ever hear a technician say, well, your liquid line service valve's leaking, that's going to be your small line. Your suction line is going to be your big line. So we talked about heat pump and AC. Straight AC modes, this will be ice cold in the summertime. Be cold. The old timers back in the day when I first started here, hey, check that suction line. Feel it. I said, okay, what does it feel like? Bear can cold. That's what they used to refer to. If it was bear can cold, the charge was good. We don't do that anymore. We now actually have to, by manufacturers, have to check it by subcoolant or superheat. Okay, and I'll do that another video on subcoolant and superheat to make sure your charge is proper on your heat pumps and your AC units. Okay, so 2 of these: suction service valve and discharge. Summertime, this one will be cold. Small one will be hot, warm. It'll be hot. In the wintertime, this becomes hot and your discharge becomes cool. Okay, so 2 of these: suction service valve and a liquid line or a discharge service valve. So that's 2 of those in your. The last thing I want to talk about, well, 2 things. One of the things is a condensing fan motor, okay? Along with that capacitor and the contactor and all these components I talked about, they all actually operate off the same energy, the same power. So if one fails, like this, there could be a reason behind that. That reason could be a weak stator inside your motor, weak windings. You know, we always want to check these out to make sure. This, however, is an indoor fan motor, and the reason why I can tell that is this is all open. On an indoor fan motor, we'll have open vanes to keep it cool. On an outdoor condensing fan motor, this will all be enclosed, because if it rains, you don't want water getting in there. So these will all be enclosed together, okay? Condensing fan motors do go bad. The bearings go inside. They start to wind, or they'll just quit forever. Sometimes they'll start to slow down. As they heat up, they slow down. That could raise your head pressure on your heat pump and cause some, or your AC unit cause some problems. Condensing fan motors are pretty common, along with capacitors, to go bad. And the last thing I want to talk about, which I don't have one here, which I wish I did, is a compressor. The compressor is your main heart of your system. And what that does is it compresses. It's exactly what it says it does. It compresses. They have many different ones now, but the most common one is a scroll compressor. It has plates inside that move back and forth. It actually compresses the refrigerant. And I'll probably get a lot of people, oh, it can't do that. Yes, it can. As long as it's a gas. You can't compress liquid. Nobody can. Doesn't work in automobiles. It's not going to work in a compressor for your AC or heat pump. What it does is, and that's where these metering devices come back into play, is when we change the state from a liquid to a gas, we then allow it to go back through the reversing valve and into the compressor to be recompressed. That's how we get our heat from our refrigerant. We compress it, we transfer the heat from the outside into the condensing unit. We'll pull the heat out of it in the summertime. We're pulling the heat out of your house. So they look like a tin can in the middle of your unit outside. The best thing I can tell you on that is it's enclosed, it's hard to test. You need there's a special meter that you put on them called a megometer. You can meg out a compressor, is what we refer to as megging it. We also can ohm it, ohms of resistance, or check it to ground. Compressors will short out in the summertime because they're running. Look, all these components we talked about today are in your heat pump or AC unit. The one thing I want to tell and be clear about all of these is a lot of these are movable parts, and they move in and out. Contactors move in and out. Expansion valves are always metering. Reversing valves are always moving. Service valves, flow refrigerants going through. We have filter dryers on there. Excuse me. What I do want to tell you is some of these components need to be maintained. You need to have them checked out periodically. I'm not saying you have to do it every month, but do it periodically. We prefer, and I highly recommend, a maintenance contract either with D&L or with somebody else, that they come out twice a year and they look at it, because you're going to prevent these simple contactors from going bad or replacing them before the summertime hits and it's 100 degrees outside and you're trying to find a service technician, or one of your components is getting ready to die. Your capacitor is very, very weak because that's stored so much energy in it that you want to turn around and make sure that that stays up and running to where you need it to be. Compressor, like I said, I don't have one. I wish I did. I could show you. It's a tin can. It brings, gases in, compresses them, and pushes them back out. And it pumps refrigerant as a gas in and out of the compressor through the outdoor condensing coil, through the reversing valve into your home, produces heat. We take the heat out of the refrigerant, and that's how we get heat or air conditioning. Whether it's heat or air conditioning, we're pulling it either from the outside in or from the inside out. That's how heating and air conditioning works. Hey, if you got any questions, feel free to send me an email at AskTheDandLGuy@gmail.com. If you found this, look, this is educational only. This doesn't mean because I laid this out for you to go out there and stop playing in these components. Tell you right now, this thing right now, if you put your fingers across this on an energized system, it will knock you on your butt. Do not do this. Call the professionals to have that looked at. Contactors. This is 208 volts. You do not want to get shocked by that, okay? I don't recommend you go out there just because I laid all these parts out and start saying, oh yeah, I know what that is, and put your finger in there and you can get electrocuted. So this video is for informational purposes only, and it does not in any way, shape, or form tell you how to repair your system. And I don't recommend it because there's a lot of components in here that you can seriously get hurt on. So, till next time, AskTheDandLGuy@gmail.com or visit us at our YouTube channel at D&L Mechanical Services. Remember to hit that subscribe button. And you hit that button this way or that way, it's one way. Hit that subscribe button and you'll get our videos. But that's it in a nutshell of our heat pumps. A lot of the little components. But thanks for watching. We really appreciate it, and stay tuned for more coming out next.